Wonderful, wonderful to be here. I've also got something small but wonderful for you. Today I will have no PowerPoint whatsoever. We're just going to do a demo from beginning to end. And I wanted to focus on one particular aspect of what Ross was just talking about, the ability to set yourself up to be really, really excellent at change, to embrace change. And that requires not just technology, that requires the right culture, that requires the right organizational structure, that requires embracing people who want to change and looking for talent specifically around not just hyper-specialization, but the desire, the drive to go ahead and innovate. How do you find that talent, right? How do you unleash the potential inside your organization by finding the right talent? And that's what we're going to focus on today. So, to that extent, let's start with the way that we normally look for talent. Here at MuleSoft, we very often start by going to LinkedIn. I'm sure you're all familiar with LinkedIn. LinkedIn is, you can look at it as a SaaS application. It's got a user interface. You can run searches on it. In this case, we're looking for an embedded systems engineer. You'll see why in a little while. And you can look at it just like that, or you can actually look at it as an API. LinkedIn has opened up its API. You have to sign certain agreements with them. But through that API, you can run the same things that you can do through the user interface. And so we can plug LinkedIn into the application network by leveraging its API and connecting it to other things. Let me show you how that actually works. So what we've got here on the top is our HTTP visualizer. I'm going to go ahead and clear some of the requests so you can actually see some of the API traffic going back and forth. And here at the bottom is our new API console. I've removed it a little bit from our platform. Mark will be talking more about where this will appear inside of our platform. And I'm going to go ahead and show you the LinkedIn API. Now, this isn't directly the LinkedIn API. We've actually taken LinkedIn and wrapped it with a system API that exposes just the capabilities that we actually want with respect to LinkedIn. And so here it is. It's got a very simple structure. And down here, there's the get method to allow me to go and search for candidates. So I'm going to go ahead and try this. All of this is automatically generated off of just that RAML spec for LinkedIn. And here are the various search criteria. Just like in the user interface, I can enter these, and I can go ahead and send and see what we come back with. Now, what we come back with is a JSON payload of a few people. Don't know if you can see this, but it says there are 6 candidates there. Now, it's a little bit hard to actually parse through that as a human, but we've got this handy-dandy tabular visualization that we can turn on and actually see it as a nice table. And here's 6 candidates that come back with good information about each one of them. Now, 6 candidates is great, but I'd like a lot more. And so how do I leverage my application network to help me find more candidates inside of LinkedIn? Here's another application that you might be familiar with. It's called Glassdoor. A lot of people look at it for things like rating companies and so on, but they've actually got a lot of very interesting information that, again, they've exposed through APIs. So to plug Glassdoor into this thing, we looked and we found something called a job progression API inside of the Glassdoor API. And what this guy allows you to do is look for jobs that people had before they got to a certain stage in their career. So if we use that to see what are the jobs that people have before they become an embedded engineer, we might be able to enhance our search and find more candidates just about to be there in that stage. So let's go ahead and do that. I'm going to pull up the system API we exposed for Glassdoor. Again, it will automatically generate documentation for me. I'm going to go ahead and look at the job progression API and issue a GET request on this one as well. And when I go ahead and search for people who are now embedded engineers, I realize that in the past, there were different positions for this. In fact, there's a whole bunch of them here: senior software engineer, programmer, software engineer, and so on. And I can take a certain subset of those and go back into LinkedIn and run the search again on people who have those previous titles to generate a longer list of candidates that I can go and explore further. Now, of course, I can just do that once, or I can do that as a repeatable process by exposing that as an API. So, of course, that's what we did, right? Much better to expose it as a reusable resource so we can do this over and over again. So we've created a candidates API that you can plug in more and more sources of data to find more and more candidates and keep it as a constant API so that whoever needs a feed of candidates doesn't have to be aware of the system behind it getting smarter and smarter. We implemented that with Mule, and let's actually see what that looks like. So I'm going to go here to my candidates API. And you can see it's an extremely simple API. I give it the various criteria here. I'm going to go ahead and try it. And if I want to know which one to actually hit, the documentation's embedded here. I'm going to go ahead and do a 3, which shows me the particular sources, and let's see what information I get back now. So remember, this is enhancing LinkedIn with information about previous careers from Glassdoor. And when I send that in, I realize I've got some extra stuff in the URL here. Let's go quickly correct that. This is a live demo in case you're wondering. Let's go ahead and send that request again. And what do we have now? Okay, much, much better. Now I've got 36 different candidates. A lot richer information about them. So my pool of candidates is getting bigger. Can I do any better than that? Well, it turns out that a lot of the information, a lot of the interesting candidates may already be working for your organization somewhere. Can you somehow tap into that? Do you have another source of information like that? Well, we have this thing called Slack. Now, I don't know how many people here use Slack, but at our organization, it's become absolutely prevalent. And there's a ton of wealth of really, really rich information inside of there that if you were smart about how to mine that, you might be able to find a whole bunch of hyper-specialized talent inside your very own organization. And so, of course, that's what we ended up doing. We're going to search for certain keywords inside of our own Slack and reveal the people who actually have been using those keywords, and more importantly, the people that other people have been asking about that, because that's an indication that the environment knows that these people are actually experts in that field. So let's go ahead and add that. If I hit the Slack API, and remember again, this is a specialized system API for Slack, and I go find other candidates, let's go try that one. Again, I'm going to look for embedded software engineer. I'm going to look for at least 7 times mentioning these particular keywords, and let's see what we get back from this one. All right, we've got another 4 candidates, really interesting people. Some of these guys are actually in the audience that have been associated with these particular keywords and may well be experts in this field. So let's go ahead and just plug that right back into our existing candidates API. Remember that we don't really have to change it in any way, but I do want to start showing you these layers of APIs and how they build up. So I plugged Slack into the back end of this candidate API, and everybody who is consuming the candidate API can continue to use it as is. They'll just get better sources of candidates. All right, that's great. Now, what's the next step here? All right, the next step is I want a lot richer information. So how do I get that richer information? I can find extra information here from other sources, right? So as it turns out, I can get a lot of candidates, but I don't necessarily know a lot about those candidates. So if I do want to know a lot about these candidates, I need to go outside the normal sources and try to find these people and look for their activities. Now, we picked a couple of external applications here. One of them is Meetup. Perhaps you're interested in people who are going to meetups or presenting at meetups and so on. Or GitHub. Perhaps you're interested in people who are going and either creating or contributing to open source projects or just generating a lot of activity on your own internal GitHub. And we've plugged those systems in and tried to see how can we actually enrich this information that we already have. So I'm going to go here and look a little bit at Meetup information. Again, it's a system API. And I'll go ahead and post the list of candidates that I generated before and see if I can generate extra information about these people. So here we go. Let's see what comes back. Okay, I've got 40 people. Why 40? It's the 36 that I found at the beginning plus the 4 that I found on Slack. Remember, we've enhanced that candidate API. And we've now got a bunch of information. Unfortunately, there's not a lot of activity in these embedded systems engineer around Meetup. I guess they're a little bit too embedded in this case. Okay, well, let's go take a look at the results that we get out of GitHub. If we pop up the GitHub API and send that same list of people to it, here it is. This is an enrichment API. And with that enrichment API, if I go ahead and try that, what kind of information do I get back? Okay, now I get back some interesting information. Now I'm starting to see the number of Git repositories that these people have created or are part of, the number of forks of their own repositories, indicating that other people have actually forked that, have found that useful. And there's a Git score that's actually calculated to show how active and how popular and how respected you are on GitHub, which is a great signal for how does the community know about you. All right, so now that we've got all of this rich information, what do we want to do? Of course, we want to combine it together with that list of candidates and get me a tremendously rich and long source of information about candidates that I'd like to go and resource. So to do that, we've created a candidate enrichment API. And that candidate enrichment API, I've shown you here the implementation of this. And we're going to plug that candidate enrichment API right into the list of candidates and create a Candidates 360 API. Candidates 360 gives me all the information I have about as many candidates as I can possibly find out there. And it's the one place to go and find a very rich treasure trove of candidates. Let's actually look at it here. Here is the Candidates 360 API. And there's a lot of information I can get about individual candidates. I'm actually going to go for all of the candidates in this case. And I'm going to try it. Again, I get all the documentation automatically generated. And when I send that out, same problem as before. Easy to correct. And the answer is 40 candidates with a tremendous amount of rich information about each one of them. You can go through one after the other, and if your job position is a little bit more popular than embedded engineers, you'll get even more information, and it's a wonderful tool to start sourcing. And you immediately realize, I've got a little bit of a problem, because there's too much information in here. In fact, what I'm going to do is I'm going to run this again with something called a flattening command. So here, I'm going to say flatten of 0. And what that does, again, I have to change this. What that does is it gives me a different representation of exactly the same information as we had before, but now as a flat table. So I haven't changed the information, but I realize why I'm having such a cognitive overload. There's just too much information in this table. And so the question is, what can we do about this? Is there anything that we can do about this guy to allow us to process this better? And of course, we go back to the application network to help us out with this embarrassment of riches. So what can we do here? Of course, we're going to leverage artificial intelligence and machine learning, right? We should have something out there that actually helps us do this thing. And so there's something called the Google Prediction API. And it's a very, very straightforward API. What it does is you send it a table of data, and you say, I want you to predict this particular column of data from all the other columns of that data. And we're going to put this together with Workday. Why Workday? Well, let's just go all the way with this. What are we actually trying to find in these candidates? We're trying to predict the ones that are going to do spectacularly at MuleSoft. And how do we measure that? Well, at MuleSoft, probably like many of you, we have these yearly performance reviews. We want the guys who get a 4 or 5 out of 5 on those performance reviews. So what we did is the following, right? And don't worry, we didn't violate any privacy. We found a way to do this. We took a whole bunch of really rich information about people at MuleSoft. And we took out the performance reviews, and we put that together. And we got this wonderful spreadsheet. And I'll show you what it is now. of information that tells me, here's the performance review for a person who has these particular metrics. Here's the performance review for another person who has these particular metrics. And we wanted to see if the machine can predict, if we had the metrics, what will be their performance review. We want to hire the ones who are going to get a wonderful performance review. Can we teach the machine to actually do this kind of thing? So let's see how we can do this. I'm going to actually show you this using something called the API Notebook, another part of our platform, which is going to go directly against the Google Prediction API. And we're going to train it to recognize these signals, and then we're going to see how well it actually does. So if I refresh this particular notebook, we're going to start from scratch here. Remember, this is a live demo. And of course, we get that. And we're going to be taken right back into our notebook. And in our notebook, we're going to go ahead and train the system at the beginning. So the way that this works is you point it to the RAML spec for the Google Prediction API. It will automatically generate a client for that API. And then it's going to start configuring that client and authenticating me to actually be able to hit that Google Prediction API. So when I do that, it's going to ask me to authenticate. I'll go ahead and say yes. And because I was already logged in, it authenticated me with my credentials, and I'm off to the races. So now I can use the Google Prediction API. For example, I can see all the models that already exist there. Let's go ahead and make that call. And I see that there's a whole bunch of models that have already trained on that data previously. That will save us a lot of time here. Now, I can train it with data that I literally just copy-pasted from the Excel spreadsheet, right? Here you see on the left, here's somebody who got a 2 based on these metrics. Here's somebody who got a 5 based on these metrics. So the metrics are stuff that we can get from LinkedIn and Glassdoor and so on. And the performance review is how they ended up performing inside of MuleSoft. We can train the model by simply sending that data to the machine, not telling them anything more. Now it will say, you want to retrain it? Because I already know this data. And I'm like, no, you're good. So we're going to not train this again. It only takes a few seconds, but I don't really have those few seconds. Or I can take 1,000 records in there and train it on something much more significant. So I'm going to do that as well. Data uploaded as a file. And I'm going to run that. And it'll say, you want me to train again on the whole 1,000? And I'm like, nope, you know what, you're good. Just keep your training from before. And let's actually see the model states. Let's see how well these models are doing. It says the status is done and the status is done. So we're all set to go. The machine thinks that it can make predictions. Remember, we have 2 of them. One that was trained on just like 17 records and one that was trained on 1,000 records. Let's see how well they predict. Okay? So let's go ahead and give it a bunch of ratings that we found from our candidate 360 and see what it thinks that this candidate would have gotten. It says that this candidate would have gotten a 5, right? The highest in our performance review. That's pretty good. And now we're going to see, both for the inline and the file one, how well they can predict. They both say that this candidate would have gotten a 5. Now, is that always going to happen? Not quite sure. So we're going to have a way to test this model. And we're going to give the test about 10 records or so of raw candidate data. We know the answers. The model doesn't know the answers. And we're going to see which model performs better. So to do that, we send that data in. And what we see is that this one says, you know what? 5 really is a 5, and that's good. It predicted it properly. But in some cases, it got it wrong. This guy would have been a 2, but the model predicted a 5. All right, so how do the models rate against each other? Well, the inline predictions with just 17 records or so got 8 out of 11. But if you gave it 1,000, it gets all 11 out of 11. Showing you that you can really start to see how well a person's going to end up performing if you've got enough rich data behind them and a little bit of the power in the application network. All right, and with that, we can actually create an API that embodies all of that together. And that API will be called the Candidate Ranking API. We've implemented that. And this thing can actually rank and make a prediction for how well somebody will end up performing. And when we wrap that up together, With the previous candidate API, now we've got this super powerful, very smart kind of API that says, here are the top candidates you want to look at, the ones that are most likely to actually perform well for your particular organization. Of course, you can specialize these parameters, so you can look for pretty much any job description that you're looking for. Let's see how that one is working. So we're going to go back here and look at that very simple top candidates API. And we're going to do a get. Try it again. And let's see what names come up. 3 names come up as the people you really want to go after. 1, 2, 3. We obviously had to change the names from the ones that really come up to not embarrass them too much inside of this demo. So this is how you want to leverage the power of an application network to actually get better and better at sourcing the great talent. Now, this search for great talent isn't limited to just software jobs. It isn't limited to any particular industry. This can then be leveraged by other parts of your organization, and in fact, other organizations just as well. So now we're going to take you to a completely different industry than what we've seen here today. Now, again, this is a live demo. We've been having some interesting networking issues. So we're going to see if some of this stuff actually works today. But where we wanted to take you next, as soon as the crew comes back up, is we wanted to actually take you to a factory floor. And on this factory floor, we're going to have automation, we're going to have robots and all that good stuff. Let's go ahead and unveil the factory floor, unveil the arm, and let's see what the guys have built back here. All right, so we've got a whole automated factory built up. Why not, right? This factory is particularly good at the one physical thing that MuleSoft produces, which is squishy mules. And we have a robotic arm here that knows exactly how to handle these particular squishy mules. That's the one in blue. Of course, we couldn't be satisfied just buying an off-the-shelf robot. We are hyper-specialized. We 3D printed our robot to be exactly what's needed to handle our squishy mules. And that's what the area of hyper-specialization actually allows you to do. Now, it's a factory floor, and that robot, just like real factories, is fully instrumented to measure temperature and measure whether it's being blocked and so on. And even though the robot is completely specialized, the sensors and the APIs that they expose are completely standard, right? You actually want that. And the reason you really want that, oh, there's another part. Actually, I skipped a part of the demo. So you know what? I'm going to go back to that part of the demo because I think I've got time to actually do that. Okay? This one is actually fun. Just before we get to that factory floor demo, there's one other thing that enables the rest of the company, including people on the manufacturing line, to use this better, right? Which is a better interface than sitting at your computer and sourcing talent that way. So I'm going to show you how that works. What we've done is we've taken a couple of APIs from Amazon. These are called LexA and Poly. They're just in the process of being released. And what they do is they give you a chatbot interface. And so we've taken our top candidates API, and we've hooked that into that chatbot interface to allow anybody across the company, even if they're sitting on a factory floor, to actually interact with them. All right. And so to do that, we've created a service called MuleSoft. And with MuleSoft, you can actually talk to it interactively about the great talent that it's been able to source. So MuleSoft talks to the top candidates API, talks to LexA and Poly, and gives you a very nice interface for this kind of thing. Okay, so let's go ahead and pop up MuleSoft. Here she is. And with MuleSoft, I can have just a normal conversation I would have with anybody at the company, right? So I can say things like, find me a candidate.
Would you like for me to search for a candidate using your custom search filters?
You know what? Please do.
I found a candidate with 3 patents, 0 Git forks, and an average tenure of 2 years. Would you like me to Slack you their details?
Not quite sure. Let's see first. What company does the candidate work at?
The candidate currently works at VMware. Before that, he worked at Amazon for 5 years. Is there anything else you'd like to know?
Yeah, you know what I'm really interested in is who was the lead on their most popular project?
The project lead was a project manager who works at Asana. I can Slack you the contact information. Would you like that?
Okay, that's what I was looking for. Yes.
Okay. I've sent you their information.
Okay, so that's the kind of interactive interaction, conversation I would like to have when I'm presented with very rich material. All right, we're just getting started here. Thank you. All right, so now we take you back to our factory floor where people are sourcing talent, but you know, the reality is that this stuff is very automated already, right? So we have all of these sensors installed on that robot, and because they have standard APIs, we'll be able to do some pretty neat things about them. So here's one way to look at the application network and the IoT devices on there, right? Putting APIs on top of the actual things in IoT elevates them, allows them to plug into the application network and leverage all of the power that's inside that application network, right? It puts them into that one plane that lets you interoperate between all of these things. And so that's exactly what we've done here. We've put standard APIs. This is defined by the Open Connectivity Foundation. They've standardized on RAML the APIs that describe all these things like fans and switches and light detectors and so on. And they've published all of those as standard specs. So manufacturers can just install this standard API on top of it, and everything should be able to actually plug into this. Here's one example of the temperature sensor. It's a RAML spec for this. And you'll see what power we can get out of that standardized capability. What we've done, of course, is we've tied them together into a single factory floor API that exposes all of them in just the way that we need to. And then we've attached that to a factory dashboard so you can actually see what's going on. Otherwise, it's just magic behind the scenes. Now, IoT is not just the Internet of Things, it's also the integration of things. So that integration of things is what allows the various parts of the factory to be smart and respond to each other. Now, do we actually have a network down there to get this done? All right, we're going to give this a try. Because we have so much wireless interference here, some of this stuff was kind of iffy, but I think the crew may have managed to switch things out literally while I was talking. That's why they were running around here. And we'll see if we actually get this stuff to work. All right, wonderful. So first thing I'm going to show you is the factory floor dashboard. There's a simple dashboard here. And what it does is it's constantly talking, or will be as soon as I turn things on, with the various sensors on there. Okay, so as soon as I turn this on, it's going to start making calls to that and trying to register the temperature. I'm still seeing 0 degrees Fahrenheit. There we go, 71 degrees. All right, that's the actual temperature on that arm. We see that the fan is off, no problem at all. We've, of course, wired these things together so that they can regulate things properly. Okay, so at this point, we're going to actually turn on that arm and have it start going through its motions. See if we can do that. All right, awesome. So the robot is doing its thing with squishy mules. You can wonder what value it's actually adding by picking that mule up and down, but it's just for demonstration purposes for now. And while it's doing that, perhaps it gets a little bit overheated. So Brian's going to come out here and actually show us what happens if he places his finger on that temperature sensor. What should be the effect? Now, the integration is running up in the cloud and says, you know what? As soon as that's the case, I'm going to actually, as soon as the temperature gets above 82 degrees Fahrenheit, he's going to try to turn on a fan and see if he can't cool down his own arm. Okay, there goes the fan. It's indicating that it's on, trying desperately to cool down the thing. If Brian removes his finger, the temperature should fall back down, the fan goes off, and the factory becomes self-regulating. And even though this is a pretty simple explanation, over time, more and more of these things can become smarter because that's all happening in the application network. Okay, that was a very straightforward integration of things. But the IoT is also the intelligence of things. And that intelligence will evolve. Some things require a lot more intelligence than just that. So what kind of things require a lot more intelligence? Well, how about security and facial recognition, right? So in order to explain how that works, let's take a little bit of a look at how facial recognition actually works. First, let's start with the brain. So the way that it works in the brain is your eye, your retina, sees some light and dark spots, right? Maybe with some colors. And then as the signal from your eye travels back into the brain, it goes through certain layers that scientists have now identified very precisely. And what those layers do is they start to say, okay, here's an edge. From a few edges, I can detect there's some pattern. Maybe there's a feature here. And they keep going through layer by layer until at the end, they say, you know what, this is likely to be a cat. That's literally what happens inside your brain. You can see that through functional MRI. It's really cool. And so facial recognition and deep neural networks actually go through that same process today, and they're powerful enough to actually work very well. What you'll see through facial recognition is that you start to look for those edges, and then you'll start to put edges together into features, and then you can start identifying those features with certain faces and doing that recognition. Let me actually show you what some of this looks like. So here, for example, you can embed some of this stuff in the browser now, is an edge detection algorithm running inside of here. And as I do various things, you can see that it's picking up just the edges. Right? And this is the kind of thing that allows the computer to just focus on what's important, not everything about my face, just the edges. Okay. And then, once it has the edges, it can start to say, you know, this looks like, these two things look like eyes, and here there might be a nose, and let's start to identify what that looks like. So now it's able to identify, look, there's a person there. In fact, that person is likely to be male. I have not programmed any of this stuff in. It can just reload the page. It just works. Amazing. My age seems to be fluctuating rather rapidly, which I kind of like. It tends to be going down. I can be disgusted. I can be very happy. I can be sad. Well, it's actually hard for me to be sad. But I can certainly be surprised. It's amazing how much this actually can detect. And once it can detect these features and it sees that it's a face, it can send it back to that deep neural network and say, okay, who does this person actually look like? So to do that, what we've done, of course, is we've taken all the faces of people who work at MuleSoft. We have that inside of Workday. We pulled that out, we threw that on S3, and we started to train the Amazon recognition, facial recognition system that has deep learning to try to see, okay, are you a muley or are you not? In order to demonstrate that, we've got a security camera on the factory floor. Now, that security camera is not particularly smart, but it does send all of its information up in the cloud, and so we'll be able to actually leverage all that smarts in the cloud to do some facial recognition here. So I'm going to go ahead and turn on that camera on the factory dashboard. Here we see a feed from that camera. It's got a glaring light on. I guess it moved just a little bit, but we'll see how well we can actually do. Okay, so as soon as Brian comes back up and unknowingly stares at that camera, we'll see if the camera starts to recognize him. Yeah, it looks like there's a face. I'm going to take one of these faces, send it back to the back end, and see what it comes back with. Oh, amazingly enough, it's Brian Yee. All right. That was not pre-programmed, and later on the show floor we'll have this running, and you can come up and see how closely we can actually get to actually recognize your face or not. All right, that's awesome. Now, it turns out that you can fake out these things pretty easily, right? So, for example, if Brian pops up somebody else's face, not so hard to go ahead and fake that. And let's see, when the camera detects that that is indeed a face, Brian, I think you're overdoing it a little bit. Here we go. And let's see who it thinks Brian is today. Brian thinks, let's try that again. Looks like it isn't quite sending. Here we go. Sent it in, and that person is Ayang An, amazingly enough, somewhere in the audience. So you can fake these systems pretty easily today. I guarantee you over time they'll become a lot smarter. It'll be a lot harder to fake them because, again, they can evolve very rapidly through specialized services up in the application network. All right, that was awesome. But we've got a little bit more. I know I'm running short on time, so I'm going to try to go a little bit faster. Now, some things are easy for machines to react to, like the temperature getting too hot, right, or facial recognition. Some things machines can't really react to, and that's really where humans come in. Humans come in for the exception handling. Humans come in for creativity and dealing with certain situations that only people can really deal with. So we're going to actually do that. We're going to do that by working with an application that was developed by one of our newest customers, WorkMarket. So I've actually gone through all of these pieces. This is our facial recognition API. WorkMarket is an operating system for dispatching workers and seeing where those workers are at any given time, for automatically provisioning them inside of your Workday application, for scheduling, for allowing you to rate them, and so on, right? So it's a wonderful way to leverage talent in a very seamless way. And they have a mobile application as well, which we're going to show you here in just one moment. What we've done with them here is we've actually built a provisioning and a dispatching API that will automatically issue a call whenever there's something unexpected going on in the factory floor to go ahead and summon a technician. So to do that, we're going to go back to our factory floor, and we're going to generate a situation that isn't so easy for the robots to deal with. So let's start for now by actually showing the work market application. Brian, if you can come out for 1 second and show us that work market application. If we can switch to the Apple TV, we'll be able to see that there are a few calls that were issued before as part of testing, but that's fine. Now, Brian we're going to turn on the arm, and Brian's going to generate a situation that that robot can't deal with. Let's see what happens then. So go ahead and turn on the arm. And when that arm is doing its thing, Brian's going to come up with a whole big packing box and just drop it under that robot. See what we do with it. Okay. So we're going to wait for it to be up, otherwise that box will get crushed. That's a pretty strong robot. And when that thing is at the top, let's say that a box drops into it. You want to jump in there, Brian? Anytime now. Okay. Now we're going to deny that robot the ability to pick up the squishy mule. The robot will have sensed that something is blocking it, so it will stop automatically. What will happen here is that eventually when that API call gets called, it's actually going to turn red, and it's going to start issuing requests. There we go. It's going to start issuing requests to the work market application. Work market application will automatically dispatch a service worker, and a new call should be going up there. Here we go. And he can see all the information from the factory, and he can go to that factory and actually remove that blockage, right? No, because there's a much smarter way to do this. You see, why does Brian actually have to be anywhere near the factory? Why can't he be down in Gilroy or Vietnam or wherever it is that he happens to have that talent and go ahead and fix that blockage using the power of the application network? So the way we're actually going to do this is, of course, we're going to use another robot, and we're going to beam Brian into that factory work floor to be able to fix things from anywhere around the world. And so in order to do that, we've got the red service robot sitting there, and he's got APIs. Now, because he's got APIs, we can plug him into the application network, right? So we've built APIs on top of him. You can operate him remotely. And now we've got cameras on him, and we've got a particular heads-up display that is able to generate API calls to that service robot. Adrian's going to come out and show us that particular heads-up display. That headset has capabilities of monitoring wherever he's looking, and it's got a camera feed that's feeding off that robot, so Adrian actually can see exactly what that system is doing. Now, I'm going to show you one more thing before we actually turn that live, and that is that those APIs that we saw before, because they were standard RAML APIs, with RAML 1.0 you can actually add annotations right on top of those APIs without changing the API itself. And in that annotation, you can actually tell it, I would like a user interface right on top of that API. So even though the sensors themselves don't have user interfaces, when you're teleporting into that factory, you can actually see those user interfaces, and that's what we're going to end up seeing here in a moment. So with that in mind, we're going to take you back to that blocked factory arm, and Adrian will go ahead and teleport into the factory floor. And if we can switch to see the world according to him, it'll be interesting to see what he sees. So Adrian, who could be sitting anywhere around the world, is going to be able to launch this application and put himself in the head of the Now robot. Let's see if this works. It's pretty cool when it does, so I'm kind of hopeful that it does. Here we go. All right, he's inside. He has entered that robot. You can see that right on top of that temperature sensor and the blockage sensor, we've got auto-generated UIs that are superimposed right on that sensor. He's got a better experience on that factory floor than an actual worker sitting inside the factory floor having to measure the temperature. And we did that by connecting all these APIs together. He can control everything remotely through his leap motion, and he can move around that factory and notice, you know what? The robot's not too hot. It's, not got any problems with a fan, but it is blocked. So what am I going to do about that? Well, it's a pretty powerful service robot. Let's see what Adrian can do with that. All right, so he can control that service robot remotely, and with any luck, that service robot's going to be able to solve that problem, or rather, Adrian will. He's walking up, and he's got a very subtle move he can do to try to remove blockages. See if this actually works. Well, he nudged it. It's a good start. Let's see if we can do any better. And the answer is, whoa! All right. Well, that's probably as much as we can do. That robot can usually get up, but to save time, we're going to help him up a little bit and see if we can't. We're going to take one more attempt at knocking that box out of the way so we can continue massaging that squishy mule. No. All right. Not going to happen today. Thank you, guys. Oh, he is getting up, though. He's a very independent robot, right? So you can build in a lot of smarts into these robots. This guy just won't stop. He's a real muley. All right, awesome. So I'm going to keep going while you try to keep knocking that box out of there. I'll give you maybe one last attempt, and then we need to move on. All right, there we go. That was awesome. All the way from Vietnam. Thank you so much, Adrian. All right, that was really, really good. So what we really see here, right, is that we are not limited by physical proximity. When you've got APIs and things and you can connect them together up in the application network, you can get pretty much anything done. We've built out a really big application network, and you can look at it as a series of APIs. You can look at it as a really big application network that you can just plug pieces into over and over again. And there will be a variety of surprises when you do that, right? You're looking for talent from anywhere. You're looking for people to kind of go from anywhere in the world and to actually help you out with your search for talent as things go on. Oh, what's this? I thought we were done. LexA, what are you doing up here?
I've found 5 ways to automate most CTO responsibilities. Would you like me to find a vacation destination using your custom search filters?
You know what? We're going to have to talk about that a little bit later. Thank you, LexA. You can head back now. We'll have a conversation about this a little bit later. I guess that's a perfect timing to actually end this demo. I did want to end on one particular note, though. So we ended up building this thing over the last few weeks with a small crew of really, really talented people. And what's interesting is it was a small team, and it only took a very short period of time. And we didn't write a lot of software. We assembled a lot of software. I think that's really the lesson out of this, right? People say that every company is becoming a software company, and that's true. But that doesn't mean that you should be a software creating company. You should be able to leverage and assemble existing software and go fast that way. And whatever it is that you do end up building, expose it out again so other people can reuse it, and you can go even faster than that. I think that's the great lesson. All right, thank you everyone, and have a wonderful Connect.